put in the contract, stipulate it. You fly in a team from Bangkok to provide the breakfast. Yeah. That should be. Chocolate M&Ms, all the brown ones removed. Yeah, yeah. Just put it in the write-up. Yeah. All right, going to start on the dot. It's the dot, people. Welcome. Hot RFC. Get it while it's warmer than the food next door. Thanks for coming along. This is the Hot RFC session. We will be hearing from, I think, 11, maybe 10 people about their ideas of new work they want to discuss. The process is someone gets up, speaks for a little bit, tells you about their great idea, you give wild, thunderous applause, you find them later, you collaborate with them, and the work finds its way through the IETF. Unless it's awful, in which case it doesn't. That's pretty much it.
We do have a couple intro slides.
We have the note well slide. Oh, sorry, Philip. Many of you have already seen this, hopefully all of you, because the newcomers who are at the newcomer sessions today saw this about 100 times, and the rest of you have been to many IETFs and seen it 100 times. But this is the note well. These are the rules under which your participation applies. Even at sessions like this, these rules still apply. If you get up and make suggestions, they are covered under these rules. If you applaud, it's covered under these rules, right? Everything you do in this room is covered under these rules, so behave yourselves. Definitely behave yourselves. That's pretty much it. There are a couple of people remotely on MeetEcho. I think you're welcome to pop in the tool as well. I don't think we have space for questions in this session, do we? So yell your heckles out loudly. Don't need to worry about that. Request for conversation. So 4 minutes from go to please applaud and just cheer them until they get off the stage. Ask some questions at the bar. Shall we move on?
Practice. If we move to the next slide.
Yay! All right, I'm just going to back it up. Let's try again. Yay! That's better. Cool. All right, and with that, Philip, here's your clicker.
Okay.
Go for it.
So, you probably heard about the identity problem. Well, what if we solved it 20 years ago and we just didn't notice? And what if that solution was good old DNS? The thing that's kind of prompted me to explore this is Blue Sky, where everybody's account is a DNS handle, and you can switch from the one that they provide to a DNS account of your own. So I'm phil.hallenbaker.com, and the technical glue that makes that possible is just DNS service discovery plus OAuth 2, and that's it. And that means that my personal version of Facebook doesn't have any accounts. I reuse the accounts people have created at Blue Sky. I don't need to fiddle about with passwords and usernames and email callbacks. All that's done for me. It solves a lot of problems. If you've got social media, next thing you're going to want to do is to talk to people. You know, send them emails, do GitHub, do SSH and so on. Well, you can do that as well. A small DNS service discovery, JS contact, basically vCard in JSON, and 300 lines of some glue that I've put together with some cryptography. And you can pull my JS contact data out of the DNS in an authenticated fashion, so that you've got my PGP keys, my S-MIME keys, my Git keys, my signature keys, all the things that you might need to do an end-to-end secure communication with me. Now, we've done those two pieces. What about if I buy an Internet of Things thing and I want it to actually be an internet thing, not a thing that happens to talk to an app on my phone. For me, internet means the devices talk to each other using internet protocols. And I can talk to them using a web browser with a web PKI certificate. And same technology, except this time we put a QR code on the device and you can scan it, and that's all the information needed to onboard that device and get it provisioned with a DNS name and a web PKI certificate. Okay, so the objection that keeps coming up is, well, yes, but DNS doesn't scale. I mean, people did raise this way of doing things back when OpenID was starting, and we're told DNS doesn't scale. There's 32 million people using this scheme. It works. And you know what? If it doesn't, well, DNS is just going to have problems. There are people who started up DNS handle providers that provide handles to other people as a service. And if we've got protocols that we want to roll out, we can go and talk to those people and say, hey, at the moment, you're just providing people with a fancy name for blue sky. How about you do some other interesting stuff as well? And that's a way that we can start to get our stuff into people's hands. I do have a draft, Hallam Baker Any, and you can go to mplace2.social, which is the website prototype that I've put up that's using this technology. And you can also comment on the draft there. Thank you very much.
All right. You've got 2 more seconds to cheer. Yay. Thanks, Philip. There we go. All right, next one is stop leaky computing. Yeah, number 2 didn't show.
Yeah, I see.
So congratulations.
Thank you very much. So it's a good transition from the DNS. Hi, my name is Manny Fontaine. I've been coming, this is my last newbie session. I've been coming here for a couple of years now, presenting work on the universal name system and the Universal Certificate Authority, basically leveraging confidential computing at the infrastructure layer and figuring out how we can fix the internet, among other things. And so I wanted to talk about the problem of leaky computing that we have today. For those who don't know about the UNS or the UCA, it's essentially a universal version of a name system and a universal version of a certificate authority, fully automated in confidential computing infrastructure. It's for people, organizations, physical things, digital things. So as we were pitching and trying, so we're a startup, right? So we basically sending this thing, we were trying to explain the fundamental differentiation of this system. And we realized that in fact, there was a bigger insight here, that just the use of conventional identifiers, non-cryptographic identifiers, inherently leaks information. And that's because if you think about a computing process, if a process has to move data in and out or across its isolation boundary, and it's not using cryptographic identifiers, there is no way for that process to do mathematical verification of the data that's being received or to secure information before it actually exports it outside its isolation boundary. And so you have this problem that a process is leaking, needs to trust another leaky process to secure the data, and in fact, we set off that infinite regress problem. And so what we realized is that beyond process isolation that is well understood and well accepted, we need process level information isolation, whereby every individual computing process needs to be able to generate its own keys, manage its own encryption keys, and secure its own information as it moves across the isolation boundary. We presented at the last meeting what we call STEM identifiers, which are indeed random identifiers, 256-bit in length. They happen to be both identifiers within this infrastructure, and also, of course, symmetric keys, which enables us to do key derivations from the identifier itself. So you have identity-centric encryption techniques that can derive from this. And we came up with this funky graphic here to try to illustrate what we are talking about. The big blue hexagon is a process or a TE, a trusted execution environment. So a code that runs in a confidential computing chip. And what we realize is that with a cryptographic identifier, a STEM ID, you can actually unify all three types of encryption that we so far have done separately with, an OS and other things and humans in the middle. So we can secure data in use, encrypt data in use. That's the confidential computing piece. But then we can also derive keys that will secure encryption at rest, and then derive keys that will secure information in transit. So you unify all three ways of encryption so that the data is never, ever in the clear outside of the isolation, hardware-backed isolation boundary of the TE. So why are we bringing this to the IETF? Because we believe that not leaking information would actually make the internet better. I have a side meeting on Tuesday at 5 o'clock, a meeting room 2. We'll give an update and an overview of work, and then we'd love to discuss collaborations around this topic. Thank you very much.
Yeah. Thank you. All right, next up we have enabling data securely processing for AI and more.
Oh, okay. So I have notes because obviously I'm not a native speaker. So good evening. My name is Lun Li from Power Research. And today I want to share the side meeting info titled, enabling data securely processing for AI and more in future telecom networks. So the future networks are shifting, as we believe, from the traditional communication pipes to the AI inroad communication entities. And AI are becoming, one of the very important use cases based on the agreed 3GPP 60 network discussion. But however, I think the traditional security often focus on the data storage and the transmission security. And according to the many regulations, such as GDPR, the data processing and usage has to attract new security, trust, and privacy requirements. So take this AI network for AI in telecom network as an example. The AI modeling and training needs or requires to process a lot of data from user, and the AI modeling and training across different trusted domain. So the OTT, for example, in DN may require model from the operator domain, and the different operator domains may require some further learning across the domain. So a lot of interactions, and those complexity and the regulations has driven potential new technologies in terms of data processing. So about the new technology, I want to give you a very quick intro to show how the homomorphic encryption can be used to protect the privacy in AI. So let's focus on this very simple example about, I call it cat privacy. So suppose my cat is my privacy. And if my cat photo, used in the AI model function, which if there's a cat, output 1, or otherwise output 0. And normally you should give my privacy data to the functions. In this case, my cat's photo to the function. But the homomorphic encryption is a new algorithm that allows computation to be performed on the encrypted data without first have to decrypt it. So it's very useful in the AI inference, and it can be, the encrypted data can be used directly, although the network knows nothing, but it can do everything through these incredible things. So how promising is that? So basically, the side meeting will discuss how to address the potential trust and privacy issue during the data usage and the data processing. And we want to address many new technologies, such as the distributed ledger, also the homomorphic encryption used for the AI inference and the training and more, with potential usage and maybe some new potential protocols that can be defined in IETF. So we are very eager to, open wide range discussion with many professions from the AI and the cryptos and more, and we can, making some during some issues in the data processing. So several speakers are listed in the agenda. We have some professions from the Telefonica, also Huawei and the Chinese Academy, and we also, Q&A section, and please to come to the side meetings or join online to join the discussion on Tuesday afternoon in meeting room 3. So I give some minutes so you can see the information and agenda. Thank you.
All right, thank you. Next up, we have Framework for LLM Assisted Network Management with Human in the Loop.
Okay, hello everyone. I'm Mingzhe Xing. Today I'd like to share our new drafts about using large language model to assist network management while keeping the human operator in the process. And the purpose of sharing this data in the HOTRFC is to collect some comments and find some collaborators. Okay, let's start. The traditional network management faces some challenges, including complex and dynamic network environment and users' diverse and intents and demands. And the rapid evolution speed of the network and the difficulty on learning vendor-specific operations. So there are many discussions about autonomous network management in TM form, and they propose some requirements or features of the autonomous network management. They also give a level definition of the degree of network automation. We are currently in level 2 and are transiting to the level 3, which is a hybrid manner of people decision and system decision. As we can see that the large language model has shown its great success on solving data understanding, logical reasoning, and generalization problems. So the large language model offers a great opportunity on solving the network management tasks. And the network management task paradigm are transiting from mathematical modeling to the machine learning paradigm, and the large language model also offers a promising direction. This area also attracting the increasing attention of the researchers, and they have published many research papers on top-tier conferences in recent years. And the key points that I like to express in my draft is the human still in the loop. This is based on a consensus in the MRG charter. And I like to discuss the framework components that build the intelligent autonomous system and the interaction workflow and the interface between the system and the human operator. My proposed the framework includes 3 major components. The enhanced telemetry model will inject some necessary textual description and supplementary information to the raw data collected from the network devices and send them to the large language model decision model. The large language model decision model will create a task instance for specific tasks, for example, the traffic optimizing or diagnose tasks. The generated configuration will first pass the configuration validation module, and then it will pass the access control module. And finally, the human operator will audit the generated configuration before installing them into the network devices. Our drafts also consider some security issues such as model hallucination and training data poisoning. In the future, we will define the task instance management interface and detail the audit process of human operator. And we also consider to integrate the internet-based network on the audit in the mutual audit interface. Okay, that's all. That's my presentation. Now we welcome collaborators. Thanks.
Woohoo. All right, source buffer management is next. Straight up the line.
No time to waste.
Nope. Your timer doesn't start till you start talking.
All right, I'll start talking. So this starts with a story that goes back almost 15 years. I was doing remote screen sharing to my computer at home. And at that time, I had a slow DSL line. It was only 0.5 megabit. The performance was terrible, which you'd kind of expect. But I measured the network round trip time, and it was about 30 milliseconds. But when I clicked on a menu, it took 2 seconds for the screen to update. So something was not quite right there, and I assumed it was buffer bloat because I just learned from Jim Geddes about buffer bloat. But when I dug a bit deeper, that wasn't it. And this was the problem. The socket send buffer on that machine defaulted to 128 kilobytes, and that socket send buffer serves dual purpose. It holds the data that's in flight but not yet acknowledged, and that's important because you might have to retransmit it. But it only needed about 3 kilobytes to serve that purpose. The other 125 kilobytes were just dead space. And the screen sharing daemon would grab a frame, compress it, stick it in the buffer. And the sockets interface would say, please, sir, can I have some more? And it would go frame, stuff it, frame, stuff it. And it ended up with 2 seconds backlog of frames that hadn't even left the Ethernet port yet. So once I understood that, I talked to my colleagues at Apple. We added a new socket option called the TCP not sent low watermark. And we kept the bandwidth delay product to hold the data that was in flight, because you need that to keep the pipe fully utilized. But then we minimized the excess waiting on top of that. And a couple of years later, I did a demo at the Apple Developer Conference. If you get the PDF version of the slides, that's a clickable link, or you can just search for that video presentation. And it's really quite a dramatic result. And then I forgot about it. But the problem has kind of resurfaced recently, and we had a side meeting in Dublin, thanks to the 30 or so people who showed up for that, and we identified some improvements. They're listed here. We really should have specified the low watermark in time, not in bytes. I did it for macOS and iOS, but I'd love to see this on other platforms. And of course, now we have Quick, and Quick would benefit from not having excessive source buffering as well. For instance, media over Quick is never going to compete with TCP. If TCP solves the source buffering problem and Quick doesn't, that's immediately a handicap for media over Quick or anything else real time. I have this in big words because this is really important. I think this may turn out to be maybe the most important thing I've ever worked on in my career. We have had incredible advances in bandwidth, going from dial-up modems in my lifetime to symmetric gigabit fiber. But things have not got that much better. We still click a video and watch a spinning wheel saying buffering, buffering, buffering. Things are not as fast as they should be. We are fixing buffer bloat in the network, which is great. But when we do that, it's actually exposing that there's roughly an equal amount of buffer bloat on the sending systems themselves. And until we fix that, we are not going to achieve the really snappy, responsive, low latency that we're capable of. There is a draft I've submitted, which you can read. Find me here this week to talk about it. We have a mailing list, sbm@ietf.org, for feedback, and we may choose to think about adopting this in a working group next time. But for now, it's an independent submission with its own mailing list.
Thank you. Really appreciate how accurately people are hitting you 4 minutes. Fantastic work, everyone. No pressure.
There's always one outlier.
Hey.
Hi, Dan, thank you. So this is just a very brief discussion on something called object-based media. And this is moving away from linear distribution of television or consumption of on-demand or catch-up media. And it's actually a spin-off from some of research we've been doing in the UK on a project called AI for Me. So it's taking several assets in order to provide a user experience in the UK. Those assets are pulled from various CDN nodes. They're then compiled and they're streamed to the user. And this will continue to be developed as part of a research project, but we're moving into a commercialization and a limited trial phase. And in the labs, everything sort of works great. The problem that we have is at scale. So we're moving away from sort of 10, 15-second media clips into several minutes and potentially 30 minutes plus, dealing with several sort of tens of users moving into hundreds and thousands. And we've got sort of potential plans to scale this up for tens and potentially hundreds of thousands. And that's just in a kind of limited proof of concept trial. And the implications for the network are sevenfold. So we have several assets that are stored on CDNs that are attached to different points in the network. There are different types of compute and GPU function that also need to be identified and measured. And then we need to set up connectivity between those different points and blend in the user access and sort of potential delivery to long-term storage, so additional CDN nodes as well. And we're dealing with multiple layers in the network. Now, several working groups have applicable technology for deploying these types of services. But again, as we start sort of scaling up and moving away from linear-based CDN stored content onto compute and GPU-derived content that is on demand and essentially for several 100,000 users in the future at various bit rates, we're finding that there are sort of potential challenges that we need to address. So we have a sort of candidate architecture, very high level view. There are several interfaces, both north-south, east-west. There are several data models and a variety of technologies that the IETF is responsible for, all the way up and down the internet layering system. So what we'd like to do is just kind of put a flag in the hill and say, are there any other operators that are working with content providers and distributors? Maybe there are several operators around the world that actually generate their own content and provide that as a value-add service or OTT service to their users. Is this something that you are working on currently or plan to work on? Would you like to talk to us? And in the spirit of full disclosure, see in terms of the architecture and some of the technologies we're using, what works, what doesn't work, and also become involved with some of the discussions that we're having both within the IETF, but also WC3 and SMPTE, that's the Society for Motion Television Picture Engineers. Our initial focus is on a relatively recent working group called CATS, which is Compute Aware Traffic Steering, which is, has a very nice approach to identifying particular nodes in the network that need to be connected, establishing metrics for compute and network, and then setting up the paths. And then what we'll do is sort of layer on some application content above that. Of course, there are a variety of video media distribution protocols that we can use. Just mentioned Quick there. So that's kind of the next step. Thank you.
All right. Thank you. Nailed it. Good. All right, zero trust network access. Sweet. There you go.
Thank you. Hello everyone. So my name is HOTRFC. I am a senior researcher at UNOFCOM Lab of SUBCOM Tunisia. My today's presentation will be about the new draft submitted into the new working group Network Operation for Telecom Clouds, which is about Zero Trust Network for Network Clouds Interface. So the problem is that due to dynamic nature of cloud services, we need dynamic policies, and which is with the duty and the activity of the new group of network operation for telecom clouds. And the idea is to propose the zero trust network for into the interfaces between cloud and network, because we remarked some gaps as the previous IETF initiatives haven't put it into consideration the policy-based network orchestration, telemetry, and capability-aware routing. So here, in our proposed solution, we proposed the integration of zero trust network integration in between the cloud and the network with young data model, which in which the high-level objective is establishing identity-based access control, enable least privilege principle, secure the network and cloud telemetry exposure, enable continuous monitoring, ensure a real-time policy-driven security coordination, and providing a scalable and extensible structure. So here we have an example that we will more and explain it in our scheduled side meeting, which is with more use cases and application that we will invite you all to be and you are welcome for feedback and collaboration. Please join us in our side meeting, which is arranged for Wednesday morning, and this is a list address and mailing list, so please subscribe. Thank you so much.
All right.
Hello everyone, I am Osama from TU Dresden, and my collaborators are all researchers. So unlike Manu, he introduced confidential computing. We are not to sell anything. We are researchers. We find ways of what the real truth is, what the technology provides, what it does not provide, and exactly under what conditions it provides what. So that's the background to it. Thanks for Manu for providing or introducing confidential computing, but we believe it's a broken technology. For instance, all it provides is, or all an adversary needs is to break a single machine in the whole world. That's essentially a summary of what confidential computing today under the threat model is providing. And that's why it is the case. So that's one of the research results that we have, is namely the attestation key is the one which is providing you all the trust. This is the one which is signing the evidence. And as I have shown on the slide, which is the several texts such as Foreshadow have actually shown that you can actually exfiltrate the attestation keys. And the slide is showing different steps. For instance, the CSP is now your adversary, and it's claimed, it's according to the threat model which is claimed. And now it can divert the connection to any machine in the world, including its own CSP controlled machines. That is the machine CPU2 that you see on the right. And now what it can do is that it can sign the evidence with that key that it has exfiltrated. So any machine of the world, if it is compromised, all the security provided by confidential computing for anyone, anywhere in the world is completely broken. And that's what is happening in steps 2 and 3. It's creating the evidence, sending it back, but with a caveat that step number 4 is showing the certificate. It shows it that it's not measurement 2, which the actual VM on the right had, that it has compromised, but rather with M1, because then only then it can, the client can then accept that connection. And it has the power to do that because it's the signing key it has already exfiltrated. So the next slide is showing one of the another pitfalls of confidential computing. The reason we are, so the logic that we are told is that, okay, so how does the, actually, we do not have a good answer of how does the identity and the long-term key get into the VM in the first place. If that is with the CSP, as I said, the confidential computing threat model, it's trivial to break that because that's a part of the adversary. Now, the other thing which is provided, or the other logic that is provided is, okay, so it is within an encrypted workload, and it will only decrypt once it has proven its measurements. But that measurement can only be done once it has that key. So there is a back and forth between that, and that logic doesn't make sense to us. And we believe the same attack with exact specifics I have provided before applies in this case as well. So we are looking for collaborators in order to solve this identity crisis. We have a paper which is under submission, and we would very much like to have other collaborators in order to solve this problem, rather than just do marketing claims that confidential computing is providing you a lot of security. It is not. We really have to solve this problem in order to proceed forwards. We would love to have some collaborators who are knowledgeable in at least one of the 4 areas I have listed, like the TLS protocol and remote attestation RATS working group, formal methods, UFM-RG, and confidential computing. Currently, it does not have any working group, but we are interested in initiating one working group. So the side meetings, we have a couple of them. In the first one, I will introduce some fundamentals. In the second, I will go into the deep dive of the attack that I have shown. And there is hack demo happy hour, in which I will also explain the formalization of the results. And this slide shows some of the pointers to the works. To those who are interested, can very much look into it. And thank you very much for listening.
All right. Next, we have one diagram to stack them all. Yeah, sure. Gotta save those seconds.
Good evening, everyone. So I wanted to discuss with you this problem that has been bothering me for quite some time. On occasions, I get an RFC, I get a ICANN PDP, or I get a document from the Global Digital Compact or whatever, and I'm trying to make sense of it, and I'm trying to figure out what are the resources that it might be talking about, or they might be influencing, what are going to be the different layers in the stack that it might be also influencing, so that we can try to figure out how much is going to be a problem or a solution for problems of ours. And typically, normally we look at how the traditional OSI stack is, and we try to figure out those things there. And at some point, someone was making an interesting comment on and pointed me out to this page on the Wikipedia, where you have this concept of the layer 8, where you can basically have, that's the laser function? Oh yeah. So some people thought about stacking up some of the layers as to the user layer, the organization layer, the government layer. And immediately I thought there was one layer missing, that was the supranational organization layer. So when you try to analyze those documents, it would be nice to figure out exactly at which layer they are affecting. But then I also had the suspicion that only looking at those documents on one single stack may not be the way to go. And so I still don't have an answer to the question. I'm trying to figure out what would be the way to proceed, but I will be basically trying to figure out a way to diagram or to have a framework for diagramming documents to be able to understand how they affect the whole infrastructure. And so basically the request is, if there's anyone who's interested or has an idea or would like to even challenge the concept, just please come to see me and we'll discuss about it. Thank you.
All right, there's another page with some contact information, and we've already done that. So moving on to exploring trust context in a tested TLS environment. Thank you.
Dear IETF community, I am Pavel Nikanorov from Genex. We work on confidential computing adoption in biomedical research use cases, and specifically built on top of the existing efforts towards standardization of attested TLS. And we focus on exploring trust models, assessment of trustworthiness of the confidential workloads. And so what is trust essentially? Trust is defined as a level of confidence in the security aspect protection
So this level of confidence leads us to the understanding of risks behind different technologies. For example, SHA-1 has more risks than SHA-256. And it's important that trust always comes within a specific context. And different technologies provide trust to different trust contexts. For example, TLS provides us trust to the identity and authenticity of the owner of the remote workload, and data confidentiality protection during transmission of the data. And it does not allow data owner to control how the data will be used in the remote service. Attested TLS plus PKIs provides additional aspect that remote workload work inside isolation, and that's it. But current scope of attested TLS does not involve the assessment of trustworthiness of the software. And to approach this, it appears that we need additional trust anchor and specification for it, sort of a registry for audited software, configuration files, policy files. It will allow us to assess additional trust contexts, such as confidentiality of ephemeral key inside the workload, and also through the security policy files and so on, we can check that remote workload will perform some security measurements, automated response to malicious activity, and so on. And also, time is a critical dimension to trust, because we attest system at once, and we would like to be sure that system will preserve its integrity and privacy preservation measurements. And we have current ideas for the specification of such trust anchor. We have some take on formal analysis of trust context, and we are looking for collaborators who are knowledgeable in formal security analysis, trust models and frameworks, and specifically some relevant specification for stores that could serve as a registry for versioned software and with the signatures from auditors and provenance tracking and so on. This work will be conducted within the working group with the Global Alliance for Genomic and Health, strengthening organization in biomedical research, and the selected outcomes of this work will be presented to the IETF community for standardization of such trust anchor for the attested TLS. Thank you.
All right, thank you. All right, that was our last speaker. Could we please have one more round of applause for all the speakers today? Thank you very much. Good news, if you didn't get your cameras out and grab a snapshot of any of the slides, all the slides are available in the data tracker. If there's any of these sessions that you're interested in, please go find the slides, find the details of the speaker, get in contact with them. There are some side meetings. Please come along and attend them. Yes?
I want to thank our hosts for doing the work to put this together. Thank you.
That's all it is. Thank you. Awesome. Enjoy your evening and enjoy the IETF. Thank you. You're welcome. Hey. Oh, yeah, there might still be food left. Run, run, run. Awesome. Oh, yes. It's all about cat pictures. A test, maybe we did. You can't prove we didn't. Oh, go ahead. Just don't break the cat. We'll be happy. All right. Thank you.
Thank you so much. You're the whole week.
I'm here always. Try the